Okay, hopefully everyone's got the math juices flowing now. We got to get pumped up. This is a big lesson, and big because not only is it something new and different, and you're going to see it in your homework and on your tests, and again in grade 12, but there are a lot of examples, and I want to expose you to as many examples as possible. So here we go. We're going to define an inverse function, and then we're going to look at how do you get the inverse from a graph, a table of values. And then the main focus is going to be algebraically. What is an inverse function? The inverse of a function is the reflection of a function in the line y equals x. And the line y equals x, remember, is like a 45-degree line. Cuts through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 45 degrees. So it's kind of reflected on an angle almost. It's denoted like this. So f of x equals f. Now you have a -1 exponent of x. So that's f inverse of x. This essentially amounts to the x and y coordinates just switching between the parent function and the inverse function. So I'm going to say that one more time. That amounts to the x and y's just switching places. Now, if the x and y switch, likewise, the domain and range also switches between the parent function and the inverse function. Let's get into an example. We are going to find the inverse of f of x, which in this case is just root x, using a table of values and state the domain and range for each. So this is one way that you can find the inverse. So we're going to start with the parent function. So let's say we start with f of x. And everyone knows, hopefully, or is in the process of learning their parent points for root x, 0, 0, 1, 1, 4, 2, 9, 3. And we can plot those. 0, 0, 1, 1, 4, 2, and 9, 3. And we get an arrow on that end, and that's f of x. What's the domain of that function? By now we've had some practice with domain and range, so all real numbers such that x is less than or equal to 0. Sorry, I think I said less than there. Greater than or equal to 0. I wrote greater than or equal to. Range. Y is all real numbers such that y is also greater than or equal to 0. Can't be any lower than that. Okay, so there's f of x. Now we're going to do f inverse of x. Based off of one of our definitions on the previous slide, all this amounts to is you switching x and y. Of your parent function. So 0, 0, they're going to switch spots. Well, it's still 0, 0, 1 and 1, switch spots, still 1 and 1. Here, though, is going to become 2, 4, right? X and Y switch. And this one become 3, 9. So we're ready to plot our points. And some of these are the same points. So 0, 0, 1, 1, 2, 4, and 3, 9. And there is f inverse of x. Domain. Now the domains and ranges also switch, but since our domain and range was the same for f of x, for inverse it's going to be the exact same. So x greater than or equal to 0, and our range, y is all real such that y is greater than or equal to 0 as well. One more thing I want to show you. So The inverse of a function is the reflection on the line y equals x. So if I put the line y equals x on here, I'm going to put a dashed line on here, a different color. That's the line y equals x. That's your mirror point. So the red one is reflected, folded along that mirror to get to the black function. This is one way to find the inverse, depending on what you're given. However, this relies on you using a table of values and being able to graph. And this is also one that has no transformations or translations to it. It's just straight up root x. So the bulk of this lesson is going to be doing it algebraically. Then we don't have to necessarily worry about graphing or finding a table of values. Here are your steps, and you're going to want to write these down and highlight them or draw a bubble around them. First thing, write f of x as y, and that's kind of an optional step once we get good practice with it. Switch x and y in the equation, solve for y, write y as f inverse of x. So even though there's only 4 steps, they do take some time, some of them, so just kind of trying to simplify the process a little bit. So without further ado, here we go into some examples. Make sure you got some paper. Find the inverse of f of x. All right. Step number 1, write f of x as y. So y equals negative x over 2 plus 3. Step number 2, switch x and y. So that double-ended arrow just means switch x and y. You do not have to write that step every single time. I'm going to write it this first time, and then from now on, after this, I'm going to abandon that. It's just one extra line of writing. However, if that's your comfort level, you can keep writing it to help you remember what to do. So we're going to switch x and y. So this is going to become x equals negative y over 2 plus 3. Step number 3, solve for y. So we have to isolate y. So let's bring over, and there's different ways to do this. Let's bring over the 3 becomes x minus 3 equals negative y over 2. Multiply both sides by 2. So that's going to give us 2x minus 6 equals negative y. I want just y, not negative y. Divide everything by negative 1. Negative 2x plus 6 equals y. Last step. I'll continue. I'll just put it over here. Change y to be f inverse of x. So f inverse of x equals negative 2x plus 6. F of x was linear. Our inverse was also linear. Now I'm just going to include a little or. We could have eliminated that dividing by negative 1 if you realized that we had negative y. So instead of moving the 3 over to become negative 3, we could have moved the negative y over 2 over to make it positive y over 2, and instead moved over the x to make it negative x plus 3. And then we could have just divided or multiplied everything by 2, and we would have the same answer. Again, multiple ways here to do an answer. Next example, these are all find the inverse. So, change that f of x to y. Swap x and y. So you're going to notice I didn't write that step with that double-ended arrow, but again, if that's your comfort level and helps you remember what to do, go ahead, add that in. Isolate y. Bring that 10 over, x minus 10 equals 2y. Divide everything by 2. That's going to leave us with x over 2 minus 5 equals y. Last step, change y to f inverse of x. x over 2 minus 5. F of x was linear. My inverse was linear. C. Right, f of x as y. Swap x and y. This one's pretty easy. Multiply both sides by 10. 10x equals y. F inverse of x equals 10x. So again, I'm just trying to expose you to as many different examples as possible. They're not necessarily complicated. We're just going to do quite a few of them. D, find the inverse still. Write f of x as y. Swap x and y. First thing you need to do, bring that negative 2 over, becomes positive 2. Multiply both sides by 5. To get rid of that 5 on the bottom, right? 5x plus 10 equals 3y. Then divide everything by 3. Y equals. If you want to, you could leave it like that, or you could write 5x over 3 plus 10 over 3. It's up to you. And then don't forget f inverse of x, 5x over 3 plus 10 over 3. So far, anything that was linear, the inverse was also linear. Now we're moving on to quadratics. So we want to find the inverse of f of x. Same steps, y equals x squared plus 5. Swap x and y. And then isolate y. Bring over the 5 first, x minus 5 equals y squared. How do you get rid of a squared? Well, you got a square root. And don't forget that whenever you take the square root, it's plus or minus. So this is really plus or minus the root of x minus 5 equals y. Don't forget, change to f inverse. Let's think about this for a second. Graphically. So x squared plus 5, that's just a quadratic, has its vertex on the y-axis at 5, and opens up. There's f of x. Algebraically, we got plus or minus the root function. And that would be shifted to the right 5. And we got a plus version of that, so just a normal root function. But then we also got the minus, and that's like a negative a value, which means reflected in the x-axis, like that. And so there's our f inverse of x. And then don't forget, you could think of that as a reflection in the line y equals x. So if you were to fold that along that dashed line, one would be on top of the other. Just gives you a visual of what's going on here. Because we're going to do a little bit more investigative work with the squares. And we're slowly going to get more and more complicated here. So we're still finding the inverse, the quadratic. Swap x and y. Isolate y. So we're going to free the y. First thing, bring over that 9. Becomes x minus 9. Next thing you have to get rid of is that 2. Again, you're slowly peeling away stuff off the y, moving outside, inside. So I'm left with X minus 1 over 2 equals y minus 2 squared. Got to get rid of that squared next, so that's plus or minus. And your last step would be to move that 2 over, it becomes plus 2. So y equals plus or minus the root of x minus 1 over 2 plus 2. Make sure that plus 2 is not inside the square root. It's not supposed to be. And then f inverse of x plus or minus x minus 9 over 2 square root plus 2. G. Now we're finding the inverse of a root function. So y equals root x plus 7. Swap x and y. How do you get rid of a square root? Well, you square it. And this would be x squared equals y plus 7. Bring over that 7. X squared minus 7 equals y. F inverse of x equals x squared minus 7. A quadratic inverse ended up being a root. A root inverse is going to end up being a quadratic, or at least one arm of a quadratic. Again, this was not plus or minus written there out front. So this was really, if we do a little graph of this, this was moved to the left 7. So that was our f of x. And even though this was written as x squared minus 7, we only ended up with one arm of that because of that. So there's minus 7. We only ended up with one arm. Again, if we reflect that through the line y equals x. And that was f inverse of x. H. Find the inverse of fx. Whoa, this is a big one. This has got a, k, d, and c. We can do it though. Y equals -3, the root of -2x plus 8 plus 5. Swap x and y to start. And then we've got to isolate y. So we're going to bring over the 5 first, becomes -5. Bring that over. X minus 5, -3, root -2y plus 8. Then divide everything by -3. So this is going to become, now it's kind of bad, it's bad math notation to have the negative in the denominator. So this is going to become -x over 3 plus 5 over 3, if that's how you want to write it. Those are gone. So now we're here. Got to get rid of that square root. So we're going to square everything. And that leaves us with -2y plus 8. Do not square what's in brackets. Try to leave it as simple as possible. And as soon as you start squaring what's in brackets, it's going to make it that much more complicated than it already looks. Then bring over that 8 becomes -8. So -x over 3 plus 5/3 squared minus 8 equals -2y. The last step is to divide everything by -2. Now that looks really weird. It's still just a quadratic. It would have some fancy simplifying, which we're not going to get into. we're going to leave it just like this. And even though we want to get rid of that negative out of the denominator, so this would become negative out front, and that would become a positive over 2 equals y. And then last step, f inverse of x equals negative x over 3 plus 5/3 squared plus 8 all over 2. That was a good one. And again, we could simplify that further, but we're just going to leave it like that. I care more about your process for finding the inverse than I do about simplifying something kind of complicated like we got at the end there. To I. This is weird. This has got an x on the bottom. This is like our reciprocal function, right? Same process though. Y equals negative 3 over x plus 5. Swap x and y. Bring over that 5. X minus 5 equals negative 3 over y. Now this is weird. How do I get that y off the bottom? How do I get it out of the denominator? Well, we can still cross multiply. Like if we had a number on the bottom, we would multiply both sides by that number. Just because we have a variable on the bottom doesn't mean we can't do that. So if we multiply both sides by y, those cancel. Times that by y. Now I wouldn't write it as xy minus 5y. We're just going to write it out front, which still means multiply. And we're there. We're almost there. How do you get rid of the x minus 5? We'll divide both sides by x minus 5. Those are gone. You're left with y equals negative 3 over x minus 5, which is still a reciprocal function. Last step, we'll erase that. F inverse of x equals negative 3 over x minus 5. This might be one to pay attention to or to highlight, because oftentimes when we have the variable in the denominator, we don't know what to do. So that's it for the most part for the algebra version of what I wanted to cover with you. And I did go through kind of quick. So if you found the pace to be quick, that's okay. You're not alone. It was by design. You can go back and watch it. I just didn't want this to turn into like a 45-minute lesson. Lots of time to watch. So the last couple of examples here, we're going to find the inverse from the graph. So we don't have the table of values and we don't have the equation. I mean, we could come up with the equation, but we're just going to do it from a graph. So what you should do is you should pick off the key points. So if I look at, we'll call this A, we'll call this B. Starting with A, there is a key point right there, 0, 0, 1, 1, and then the next nice point is right here, 2 and 4. And we know that if you want to, you can draw this line, the y equals x line. And it's supposed to be a nice reflection in that line. Or, again, like we talked about at the beginning, coming full circle, you just flip your x and y coordinates. So 0, 0 flipped is still just 0, 0. 1, 1 flipped is still just 1, 1. 2, 4 up here flipped is 4, 2. Even though we'll say right there. And when we want to graph that, something like that. And that looks like a nice reflection through y equals x. And that is our f inverse of x. B. So again, we want to pick off the nice points. So there's a nice point at 1, 3. If I flip 1, 3, that becomes 3, 1. 3, 1. Okay. Here's another nice point. That is 1, 2, 2, 2, which 2, 2 flipped is still just 2, 2. Another nice point right here, which is 1, 2, 3, 3, 3, and 3, 3 flipped is still just 3, 3. And then lastly, we have this 0.50, which is going to become 0, 5 up here. Now, it might be kind of tough to think about what that looks like with those 4 points. So it might help you to draw this. You don't have to, it might help you. So this is going to make a nice little cup shape. And then this is going to connect to that with our straight line. And that was our f inverse of x. If you haven't noticed by now, any point that actually lies on the line y equals x, so like 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2, if they lie on the mirror point, they stay on the mirror point. Right? That's how mirrors work. Example 4a. Is the inverse of f of x equals x squared plus 5 a function? Why or why not? This is a good thinking question. Let's start out by finding the inverse. Y equals x squared plus 5. Swap x and y. Bring that 5 over, x minus 5. And then take the square root. And don't forget plus or minus. So plus or minus the root of x minus 5 equals f inverse of x. Now maybe algebraically, I mean we've seen this already today, or this lesson, but maybe this means nothing to you. So maybe we'll make a sketch. So here's x plus 5, or x squared plus 5 I should say, there's f of x. And this has been moved, or f inverse of x has been moved to the right, 5. And it's a root function, it's got a positive and a negative. So like this and like this. And there's f inverse of x. F of x, definitely a function. Passes vertical line test. If I look at f inverse of x, that is definitely not a function. That does not pass the vertical line test, right? If I was to draw a straight line or hold your pencil or ruler or whatever up to it, you would touch that line twice. Not a function. So not a function, does not pass vertical line test. So that brings us to our last question. Could we restrict the domain or range so that it is? I'm going to re-sketch that. So there was our x squared plus 5. If you restricted the domain, so the reason why that inverse is not a function is because it has both arms of the parabola rotated around. So I could restrict the domain. If I don't want to have both those arms, I could cut my parabola in half. Okay, so I'm going to draw a big thick line there. And I could restrict the domain to either be just that or to be just that. If it was just this, I could restrict my domain to be x is all real numbers such that x is greater than or equal to 0. If I do that, all I'm going to end up with is this. And so therefore, when I go to do the inverse, I would just end up with that. And that's definitely a function. Or I could restrict the domain on the left side. So I could restrict the domain to be x is all real such that x is less than or equal to 0. And if I did that, I would just be left with this part of f of x. And when I go to find the inverse or graph the inverse, I would just be left with this part down here, which I'm going to write dashed. You might see questions pop up like that every now and again. They're good thinking questions. Now the range, if you restricted the range, that's not going to help you at all of your original function. So when it comes to this, again, all we want is x is not to repeat for it to be a function. So that's why it has to do with just the domain. So hopefully that makes sense. If not, definitely ask me about it. It's not going to be a huge testing point, but you might see it pop up as a good thinking question. So we care about the domain. We don't necessarily care about the range. And when we're talking about quadratics and roots and how their inverses are related, really it just boils down to what's the x coordinate of the vertex. So whatever the x coordinate of the vertex is going to be would be your kind of branching point for where you want the domain to either be greater than or equal to that number or less than or equal to that number. Okay, we made it. Hopefully it wasn't as long as you thought it was going to be. Like I said, I did kind of go through relatively quickly, but I didn't want to expose you to a lot of examples. And remember, you can rewatch this at any speed. So that's it for this unit. By the time you watch this, hopefully you already know your test is Wednesday afternoon. You have Wednesday morning to prepare, do some more review, test Wednesday. And then if you happen to be watching this and you're really far ahead, just note that I might be changing the order of what unit number 4 is, what unit I do next, because we do have 7 days together. But that's it. Thanks for listening.